Hey guys, welcome to today's video. Given today's AI bubble and the AI craze going on right now, and as part of my thesis, I recently learned a new skill. So in the world of large language models, there's a thing called fine-tuning. So maybe you might ask, what is fine-tuning? Let's say you have an AI model that's not very good at solving chemistry problems. So with fine-tuning, you can teach that model, you can teach that existing model with a data set of chemistry problems, and then via fine-tuning, that model will help you solve chemistry issues. Namely, in this video, you're going to learn how to use Google Colab to fine-tune a Gemma 3 1 billion parameter model. So let's get started. So step one should be to prepare your dataset. To prepare my dataset, I'll be using AI. So within Gemini, I used a little prompt to give me fake information about a guy with the same name as me and with the same age as me, but with everything else being fake. So thanks to Gemini, I now have an array of dictionaries with two fields, the question and the answer. I'll now take this dataset or this JSON array and then I'll copy it. So now with this copied, I'll go to Colab, I'll paste my code, and then I want to save this JSON array to a JSON file within Google Colab. To do so, I go with open, and then let's call senddata.json. I want write permissions as JSON file, and then I do json.dump my dataset. So this is senddataset, JSON file, and let's give it an indent of 4. Then I print data written. Let me zoom in for you. So here I have a little issue. I'll go up to import JSON, all the way up, import JSON. Anyways, now I'll scroll back down. I will save it. And if I refresh, it's now been saved. I'll now create another code snippet. So what I want to do is I want to convert this JSON array into a data set. Then my AI model will read this data set for training purposes. First of all, from datasets, import dataset. And then since I'm working with JSON arrays, I have to import JSON as well. So now I have to find my prompt format. It's important to remember that for every AI model, in most cases, the format of the prompt is a bit different. So going back to Google, here I find my prompt format. So the user's prompt is marked by the user message. The end of the message is marked by end of turn tag. Then the model's answer starts here and then it ends here. So now I'll put it to the side. I'll close this. And then we have to format our prompt. So def format prompt, I'll create my function and then our dictionary. So item. And then I do return. I return another dictionary, text. My field should be text. Let's do a template literal. So start of turn and then user, then a new line and then a space. So item and then my field. So in this case, it's question. And then the end of the question is marked by end of turn and then start of turn. The model's answer should be marked by model. Another new line, curly brackets, and then item answer. So this is it for my prompt. I'll now go to another line and then I want to give myself some space. So this is not needed anymore. And then I maximize my window. So now I want to load my file from storage. So file, json.load, then my file. So in this case, it was Hussein data.json. I forgot my function. So open here like so. And then I want read permissions. And then for every item in this file, I can create another variable formatted data. And then I use list comprehension. So for every item, format prompt, item for item in file. As an example, I can print the first one. So formatted data and the first item in the array. Let's run it. So we're getting exactly the prompt that we wanted. Let me delete it. Now I want to save it as a data set. So data set is equals to dataset.from list and then my formatted data. In the end, I would like to save this data set in Colab. So dataset.save to disk and then my data set. So send data set. So if I run it, now it's been saved. If I zoom out to my file manager, I now have my data set saved locally. Let's now move on. So it's now time to use our Unsloth API. Before using Unsloth though, we have to install our dependencies. Luckily for us, there's already some documentation given from the guys in the Unsloth team. So I'll copy this code, I'll go back, and then I'll paste it here, and then I run it. Let's now wait for it to execute. Now that we have installed the dependencies, I'll now bring in my model. So from Unsloth, I import, let me scroll down, pass model, and then I use torch. So import torch. And then I'll create a model name variable, which will be the name of my model, and it's Unsloth / Gemma -3 - and then the number of parameters, so 1 billion -it, if you're curious where I got the model name from, you basically Google your model with Unsloth and then Hugging Face. So according to Google, the first result is exactly the model that we need. We don't need GGUF, we just need the normal model, which is this one. Anyways, let's now head back to our code. So model, comma, tokenizer, fast model dot from pretrained. So we get a pre-trained model first. So we have some keyword arguments. So model name should be my model name. Then we should have a D type, none. We want to load it in 4-bit mode. So load in 4-bit. This saves memory. Load in 8-bit. We want it to be false. We can set it to true, but it will take more memory, and Google Colab has very limited resources anyway. And then we set full fine tuning to false. We don't want to fully fine tune this model. We just want to fine tune parts of it. And then we want the sequential length. So max seq length to 2048. Let's now run this code. So we get an error here. This is because I'm only using the CPU on Google Colab. I'll now show you guys how we can use the GPU on Google Colab. So I'll zoom out, I'll go to runtime. Let me make the font bigger and then change runtime type to T4 GPU because I want to use the GPU, and then save. The session will now restart, and as you can see, I don't have my files anymore, but it's not an issue. I can simply run all of my code once again. So within runtime, I do run all, and now let's wait. So now with my code fully run, I can now create a new code snippet. So my next step should be to get the adapters needed for fine tuning. So I go model, let me scroll down, model, and then fast model dot get PEFT model. So this is for fine tuning, and then I pass in my model that's coming from my pre-trained function, and then the rest of my parameters. So fine tune vision layers, I set it to false. This is because we only want to fine tune on text. Fine tune language layers. So of course, since we're fine tuning on text, and by definition we're fine tuning with language, it should be set to true. And then fine tune attention modules, this is for reasoning, I'll set it to true. And then fine tune MLP modules, and then fine tune MLP modules. The guys at Unsloth recommend this to always be set it to true. Next, I would want my rank. So R, we can set it to 16. The higher it is, the more accurate your model is. But the problem is you might have overfitting issues. And then another parameter, LoRa alpha. So the guys at Unsloth say that it should at least be equal to the R value. That's set to 16. And then the adapters that we want to fine tune. So I said target modules. So I want this one. I want K proj. I want V proj, O proj, another line. And then I would get gate up and down. So these are the modules that I want to fine tune. Now I'm not really sure what any of this means, but I would suggest that you guys use AI or some other large language model to help you explain it. And then the rest of my parameters. So I want the dropout to be 0. I want to use checkpointing. So use gradient checkpointing should be Unsloth. Use RS LoRa. I'll set it to false, and then loft Q config. So we don't want loft Q, we don't want any bias, so I'll set it to none, and then my random state, so a number 3407, and then let's run it. So I made a mistake earlier, so instead of setting it to false, you have to set it to none. And now let's wait for my code to run. So now we've gotten the PEFT models. By the way, I want you guys to know that if you got a warning telling you that you called get PEFT model twice, maybe that might be an issue. I also got the same error earlier, so to fix it, what I did is I restarted the session. So I cleared all my memory and then ran all of my code again. Let's now move on. I'll now create another snippet to perform fine tuning. So first things first, I would want to import my dependencies. So from TRL, import SFT trainer, and then SFT config. Then from datasets, I import my dataset. So import dataset. So first I would have to actually get my dataset. So dataset is equals dataset dot load from disk. This is because my dataset is loaded in disk already. It's literally called Hussein dataset. So Hussein dataset. And then to perform the fine tuning, I can simply go trainer, SFTT trainer, and then my parameters. So the model that I want to train, and then the tokenizer I need. So this will tokenize all the text, and the dataset. So train dataset, which is again dataset, and we don't need evaluation. So eval dataset is set to none, and then my config, which is saved within the args argument. So args sft config. So per device train batch size is 2. And then my accumulation steps, so gradient accumulation steps, let's set it to 4. We need warm-up steps as well. So how many steps we need for the model to warm up before running steps, let's set it to 10. And the epochs or the epochs, I'm not really sure how to pronounce it, I'll call it epochs. I set it to 3. Then the steps for training, so max steps, let's set it 40. Then the learning rate to E minus 4. We set the logging steps to 1 and the optimization to Adam W 8-bit. We set the weight decay to 0.01. We set the scheduler type to linear. And again, we need the seed, which if you go up, it's random state, so 3407, and then report to none. Once again, I'm not really sure what these arguments are, and explaining them will take a long time anyway. So to repeat, I would suggest that you guys look into using a large language model or the documentation to actually know what these parameters mean. Let's now run it. So earlier I got an error telling me that I cannot perform training on a quantized model. So to fix it, all I did was to run this snippet, the next snippet, and then this snippet again. Anyways, so now that my model has been trained, moving on, I want to train my model. So before doing that, I have to train my model using my responses first. So first I go from Unsloth.chat templates, import train on responses only. And then I call my trainer, so train on responses only, and then my arguments. So the first one is the trainer I'll use, so it's the trainer itself, and then the instruction part. So if you recall, going up, the instruction part is marked by start of turn and then user. So I'll just copy it. Going down, I'll paste it like so. Here I missed a tag, and then a new line. And the response part, I'll go up once again. The response part is marked by start of turn, model, and then a new line once again. So I'll scroll down, start of turn, model, that's it. And then I'll run this code. Let's create another snippet. So now I want to check if my instructions work properly. So I go tokenizer, so my tokenizer.decode, and then trainer.train dataset. Let's get the first one. And then here we have another field called input IDs. So if everything works fine, we would have our prompt and the answer. Great, as you can see, we now have a prompt and then we have the model's answer. Okay, so far so good. Now all that's left for me is to actually train my model. So trainer.train and then run it. Okay, so now everything has been trained, but notice that my first training loss was 7, which in my opinion is a rather high number. This means that the model at the start is going to be a bit incorrect or not really accurate, but notice that as the number of steps increases, my training loss decreases as well. To improve my accuracy even further, I can run it a couple more times. So now I run it again. So now I ran this train method 2 more times, and as you can see, my training loss at the start is very low and gradually it decreases to almost 0. But one thing notice is that sometimes my training loss increases as well. According to Google, this is because of overfitting, but this is a nice indication for you guys to not train your model excessively. I'll now create a code snippet. So it's now time for inference. So I'll do fast model dot for inference and then my model itself. And then I want my input message. So messages is an array. So I want my role to be user. And then my content. So my actual message is also an array of dictionaries. The type should be text. And then I should have my text. So let's ask it a question. So for example, how old is Hussein? What is the name of his company? And then I want to tokenize my text. So text is tokenizer dot apply chat template. And then my messages, scrolling down, I want generation, so add generation prompt. I'll set it to true. Then my tokenizer, I want to tokenize my message, so true. I set the return tensors argument pt, and then transfer this text to my CUDA instance. So now I want the output. So to get the output, I go outputs is equals to model.generate. So I want to generate the answer. The input is coming from the text. So input IDs is text. I want my max tokens to be 256. Of course, you can add more tokens, but it's going to take more memory. I set the cache to true. I want sampling as well. So do sample true. So there are a couple more arguments. So temperature. So according to the Gemma team, my temperature should be 1.0. My top K argument should be 64 and my top P variable should be 0.95. And then I'll save my response like so, tokenizer.batch decode outputs, and then I get the first item in this array, and then I just print the response like so. Let's now run it and hopefully we get an accurate answer. And as you can see, this is my model's answer. So it got one thing right, is that it got the company name right, which was Innova Tech Solutions. So let me confirm. So scrolling up, finding it here, yes, my company's name was Innova Tech Solutions, but according to my dataset, what I got wrong was that my age should be 23 years old. However, the model answered that my age is 25 years old. So clearly the model is hallucinating, but at the end of the day, it proves that my model is actually fine-tuned. I'll create another code snippet. So my next step should be to save these adapters to storage. So model.save pretrained, and then I'll save it to a Gemma 3 folder. Same for my tokenizer as well. So save pretrained Gemma-3, and then I run it. So now that everything has been saved, what I want to do is I want to save my model in 16-bit format. But before moving on, I want to point out that we are running low on system resources. So here, I would suggest you guys to back up your data. So what I'll do now is I'll download my Gemma 3 model locally into my computer. If you guys are curious on how I would do that, so within my terminal, I'll go zip-r and then Gemma3.zip. So I want to zip this file and then the name of my folder. So it's Gemma-3 and then enter. Now that the zip file has been produced, I'll now download it onto my computer. So my Gemma 3 zip file has been downloaded. To clear the RAM, I would simply go to runtime and then restart session. Then I do yes. So luckily my files have not been gone yet. However, I've lost my local state. So my first step should now be to load my Gemma 3 model. So from Unsloth, once again, I import fast model, and then model, tokenizer is equals to fast model dot from pre-trained, and then my model name. So in this case, I'll be loading it from Colab storage. So it's just Gemma 3. One thing I want to correct myself on is that I'm not really loading a model, I'm just loading its adapters. So what Unsloth will do is that it will download the model locally and then apply those adapters. So max seq length, once again, my sequence length is 2048 and I want to load it in 4-bit. So load in 4-bit and I set it to true. So now to save my model in 16-bit format, I go model save pre-trained, merged this time, and then I'll save it in a new folder called Gemma-3-finetune, and then my second argument should be my tokenizer. So if everything goes well, hopefully my model will now be downloaded in 16-bit format. Now running my code, notice that it's downloading the model and then it's applying those tensors or my weights into the base model. Cool. So now that everything has been downloaded, let's create another code sample, and this time I would want to save my model as a GGUF file. This will allow me to use my newly created fine-tuned model within Ollama. So however, before continuing, I would have to install a dependency. So I'll go capture because I don't want the output. So pip install and then my Mistral common dependency. I'll now create another code sample. So from Unsloth, once again, I import fast model. I'm importing fast model once again because I plan to clear out my session once again. And again, I will load in my model and my tokenizer. So model, tokenizer, fast model from pre-trained, then my model name. So this time, instead of importing Gemma 3, I'll import Gemma 3 fine-tune. So Gemma-3-finetune, max sec length to 2048, load in 4-bit to true. In the end, I want to save this model as a GGUF file. So model.save pre-trained GGUF, and then the name of my model. So I'll just call it Gemma-3-finetune, and then my second parameter has to be the quantization type. It's very hard to pronounce. So quantization type Q8_0. I want this quantization. I'll give myself some space. So this time, as stated before, I'll clear out my runtime memory. So restart session. So with my memory cleared, I would like to give myself some space. So I'll close this. I'll run both of these code samples now. One thing I forgot to mention is that I was getting errors earlier. It was telling me that I was missing an argument somewhere. This was because of some new update that happened 9 10 hours ago. So then I added my tokenizer argument. After running it, as you can see, I now have a GGUF file. Now we're ready to run our model within Ollama. So of course, since we're low on system memory, I now have to reset my runtime once again. So let's start by installing Ollama. So curl, and then I'll go to Ollama's website instead, ollama.com. Then we download, and then I just click on copy, and then I paste. I'll then create another snippet. So I want to run the Ollama server. So then I create another snippet because I want to run the Ollama server. I'll do it using Python like so. So import subprocess.popen Ollama, serve. And then I import time. Let's just put it at the start. And then I run time.sleep. I want to wait for a few seconds for Ollama to load. We also have to build a model file for our model. So I'll create a new file. Let's call it Modelfile, of course. And now we need to get an appropriate model file for my model. I'll go to Google. Since we're using Gemma 3, I'll simply Google Gemma 3 model file. Here we have a GitHub issue scrolling down, and I'll just copy it and then paste it within my model file. Paste. So now my path to my file. So I'll just copy the name of this file like so. If you want, we can have more context. I'll just leave it as it is. And for me, it looks good. Then I'll create another code snippet. I'll do Ollama create, and then I create my model. So Gemma-3-finetune, and then my model file. So -f model file. Let's now run my code snippets. So it has to be an exclamation mark here to indicate a command line process, and I run. Now that Ollama has been downloaded, I run the server. So now that my server is running, I create my fine-tuned model using the model file. There's a typo here. I'll just add an L, then run. Now that my model has been built, I'll go to the terminal. Let me enlarge my terminal like so. So I'll see if my model has been created. So Ollama list. So now I have my fine-tuned model. So Ollama run, and then the name of my model. So Gemma-3-finetune run. Okay, so now it's running. Let's ask it a couple of questions. So let's ask it the same question as before. So how old is the same? Okay, so as you can see, the answer was pretty much accurate. Let's ask it another question. What does Innovatech Solutions do? Okay, so I think the answer is more or less hallucinated. Let's ask it one more question. What is Saint's hobbies, and what company does he own? Nice. As you can see, the answer is very much accurate. So that's it for today. In this video, you learned how to fine-tune a Gemma 3 model. Furthermore, you learned how to perform inference on our fine-tuned model, and you also learned how to run our model within Ollama. If you guys have any questions, let me know in the comment section. Till then, bye bye.